So again, we're just a quick review, define, went through the DMAIC approach, what's Six Sigma, how to run a project, voice of the customer, a little bit of homework, affinity diagrams, some Pareto charts. We got into the cost of poor quality. And then last week it was, business case and project charter. That stuff's on the test, but it's not something that I think you really need to spend too much time worrying about. And then we got into lean a little bit. And we're going to touch lean on a whole bunch of different sections. So today we're going to the measure phase, which as a reminder is, after we've defined what our project scope is, I think I have everybody on PTA plus Greg today. So I don't have Ulbrich here today, so I can talk a little bit more PTA stuff. But if you take the same thinking, for project selection, instead of a big long 8-month project, we're talking about a 2-week project or a 1-week project, same thing. And then once we've figured out the scope and what we want to work on, and now we get into the measure phase, which is really about what do we need to improve? Do we understand the problem? So the tools that we're going to learn in the measure phase, some of them are statistics, which is going to be starting next week, and some of them are going to be today, which are things like SIPOC, mapping, things like that. All right, then we get into analyze and improve control, and I'm thinking we're probably at 144 slides for measure. So I broke it into 3 so we can get through easily, and be painless. So it's understanding, really truly understanding the current process, right? How the process is measured and its historical baseline performance, because a lot of times we start down the road of problem solving without really having a thorough understanding of what the problem really is, right? And the measure phase is about, in Six Sigma, if we can measure it, then that means we understand it. And I think a great example of that is what Mr. Thayer's doing right now with that escapes project. It's just taking your time and making sure before we make any changes or any improvements or attempt any improvements that we truly understand the problem intimately. So here's the measure phase. Today we're going to cover process mapping, SIPOC, and you'll have some homework on SIPOC. Value stream mapping. We're going to get into what an XY matrix is. And then I think we're going to get we're going to get through the Six Sigma statistics, just basically what they are, the difference between, descriptive statistics, and get into some central limit theorem, just really basic stuff, which is really not too complicated. And then I think next week we're going to get into the measurement system analysis and process capability. So here we go. Hey, Greg, there, I haven't heard your voice yet.
I'm here. I'm awake.
All right. Just making sure. Just doing a check, doing a pulse check. All right. So these two are, again, I'm going to give you a little bit of homework on SIPOC. Actually, you know what? I'll let you guys make the choice. A little bit of homework on process mapping or a little bit of homework on SIPOC. So let me take you through it, and then the majority rules. All right. And
we can always do both, right?
Well, you know what? For those A students that sit in the front that want to do both, yes, you can do both. You already got your A.
Really,
right, so
Greg? Really?
Have you guys done process mapping before? Anybody?
We did a little bit here with the cat one we were talking about on Tuesday, right? Last week.
Oh yeah, we did a value stream map, which we're going to get to after SIPOC. Yep. I just kind of introduced Greg to VSM, which we're going to cover in a little bit. We're going to start
this for like diagnosing issues.
These are typically in our at PTA. These are in our SPs a lot too. Just the whole process map, right?
Okay, so without time, like with no time element to them, the value stream map there's a time element to it, like you'll see, tack time. For just process maps, we're going to go through a swim lane map. Very simple, kind of just be able to hand it to somebody. They could look at it and say, all right, I understand it. I get it. And kind of the idea behind all these tools in the measure phase is that everybody's kind of playing to the same beat of music, because remember last week we talked about the idea of hidden factories, the idea that, we think as leaders or managers that a process is running a certain way, but there's people, people find shortcuts, find easier ways. And after a while, they become the new way, becomes the norm. So what it does is it gets everybody on the same page where you can hand somebody a sheet of paper and say, yep, you skipped a step, or yep, that's it right there. It's a communication tool. And it's also, it makes visible some problems that you might want to go after. Things that you start seeing things like, two people are doing the same task at different times. You see this a lot in the office, when office tasks where, people have to, do the same task down the road. And it's like, why are we duplicating all that? So it's a graphical way to look at a process flow, and you do it step by step. And I'm going to subscribe like that. You do it very simply. There's a million shapes, color, and things you can put on a map. But I think the best results are always with what you'll see is, 3 shapes, and that's about it, and I'll show you how a swim lane map works. But here we go. So mapping the current state of the process instead of the ideal state, like what exactly is happening. So when you hear that, it means the mapping cannot be done in a conference room. We want to do the map as close to where the truth is. And I call the plant floor the truth as possible. That the old school way was a clipboard, pen, a pencil or whatever, and a timer, a watch of some kind, or, your phone to time things. But it's best done as close to the truth as you can get. The purpose is to identify the complexity of the process, communicate the focus, and there are living documents. What I mean by that is, once the map is done for a given process, don't put it in the computer and forget about it, because again, it can be used to continue to develop the process, improve it, shorten lead times, make it, make the cycle time quicker. But it's meant to be a living document. And the benefits, again, are many important characteristics about, and you can use them when we start to do some analytical tools, but we kind of see on the map all of our process inputs, our supplier requirements, our process outputs. And when we say our customer requirements or needs, we're generally talking about the person that we hand our work to, right? Or it could ultimately mean who we're shipping our materials to. So I could map a process that isn't all the way from receiving to shipping. I could make a process from that's going to get handed off to the next person, where the output is going to be handed off to someone else that may not necessarily be outside of the building. Like data collection points, cycle times, defects, inventory levels, and that's more about when we get into the value stream map, which we'll cover in a minute. But there's a lot of stuff that you can kind of put on the map. And guys, I don't know, I've been doing this a long time, and I feel like the simpler I can make the map, is few head scratchers as possible, the more I'm going to be able to get everybody involved, in thinking about it and improving it and things like that. So simple, the genius is in the simple. Anybody can complicate things. The genius is, how do I teach it to others in a simple way? And that applies for mapping. So the first thing you do, again, we identify the beginning and the end of the process that we want to map. All right. So in the back of your mind, say, all right, look, do I want to do a little bit of this for homework, or do I want to do a little bit of SciPoc for homework? And you get to choose after we're done, right? And then you got to go see the people that actually do it, because and you want to consult with them. They're the subject matter experts. They're the ones that are actually doing the process. Okay. Record the process steps and sort them according to the order of the recurrence. And I think, Greg, the job we saw yesterday, that might be a good opportunity. That's a good one to do a simple process map on, as you'll see when I get into the swim lane part. You fill the step information and plot the diagram, and then record and document it. And again, I've seen many maps that have a lot of steps. Generally, the shapes that we use are beginning and end are ovals. The process steps themselves are rectangles or squares, and any decision point, yes, no points where I go in either direction, are going to be diamonds. And that's kind of all you really need if you think about it. All right. And again, there's 100 shapes you can use, but I like simple. A process, not a swim lane map, is anytime I have to hand things off to somebody else, So all that means it's kind of like a relay race, like a certain person, let's say Department A here, they start the process and then it gets handed off to Department B and then it gets handed off to C and then it comes back to A. That kind of shows you all the handoffs. A rule of thumb is I want to, when I'm starting to do improvement activity, anytime I see a handoff, which means I'm going from swim lane to swim lane and back to this person and back to this person, it costs hours or days as a rule of thumb. Okay, because basically handoffs are not good. And that's kind of what you want to go after in terms of improvements is how do I eliminate, why would I have to hand something off to somebody else? Well, in a lot of cases, it's because that person, I don't have enough information or I haven't learned enough to do what they can do. All right, so the fastest cycle time, and again, as a lean thinker, the fastest process time equals the highest quality and the best return, the best profit. Okay. So again, the beautiful, when you look at a process map like this, and I think this is just a made up process just to show how a swim lane works, but the handoffs are time, days, usually hours or days. Because you give somebody else, well, they got to wait till tomorrow or they got to wait till next shift to start it. It goes in their queue. So the strategy is always after a mapping process, when you get the team back together to say, how do we limit the number of handoffs? And you're going to get better quality, faster, higher return on investment in terms of you're going to make money. So, okay, so that's one option for homework. Option A, we'll call it. And then I know for Greg there, it's going to be option A and B he wants to do. He's already chomping at the bit, but here's option B. All right, here's another way of taking a process apart, looking at it and try to understand the truth. And it's called a SIPOC. It's a high level. Have you guys done SIPOC at all? Anybody?
No, I have not.
Okay. So it's the same thing. It's a way to take a process and find the truth. All right. And, make sure that everybody agrees. Again, I think all these things are done with, what I call an A3 team, which is 3 to 5 people. You don't do these things easily alone. All right. It's better to get consensus to make sure that we're getting the truth down. And it's applied in the measure phase to better understand the current state of the process. It's a high level tool to identify and link the different parts of a process. All right. And I think you'll find it pretty cool. So SIPOC is an acronym that stands for suppliers, inputs, process, outputs, and customers. And that's how obviously a process flows, right? So a supplier is anybody who provides raw materials, services, or information. Doesn't have to be a vendor. It's anybody who supplies it. Again, it could be the cell before. It could be molding. They're a supplier. Inputs, the raw materials, the information, the equipment, the services, the people, all that. The process itself, what do we want to do, right? In that process step. And usually it's a noun and a verb and a noun, like move pallet, or you'll see feed dog. We're going to do a feeding a dog one. And then the outputs are the services or products that are delivered to the customer. And then the customer are the end users. And again, when you're thinking customer and continuous improvement, it could be the next person I'm doing the work for. And when you guys, that was probably in my own business, the single biggest aha moment was when we start to think of the next person as our customer versus we're all working to satisfy the outside person. Once we started thinking that way, it changed the game completely. The benefits are detailed information, more details, more than the process maps. I think it's maybe not more detailed, but I think it's more visible. It's easier to kind of comprehend. Sometimes you got to read into a map a little bit. It visualizes and narrows the project scope, because in the define phase, we might have picked a project that is just too big. It's going to take us years, like the project that Greg's going to be starting for the Boston hospitals. That's a huge scope of a project. So it's like, okay, now what part do we bite first? So it helps with scope. It's a good communication tool. And again, it brings in our suppliers, the people before us, and the people after us. Because again, what kills us is this silo thinking. All right, I did my work, push it over the fence, and now it goes into a queue. And also, you know what? If the product, if there's a quality issue, well, you can always go blame one or the other, right? They did it or they did it. This eliminates, it helps eliminate the silo thinking, right? Which really helps you get to the truth. And this is how you do it. So step one, you're going to vertically list 4 to 6 high-level process steps. All right. This is how they go. This is where we start the process. There's one, and again, it's a higher level, so you don't need to get into the grainy details of the process. And step 2, so you start in the process, and I think it'll make more sense when I get into the feeding the dog thing for you. Then the next is my outputs. So I start the middle first, then I do outputs next, and then I do customers. And as you can see, each step might have a different customer. If I have to hand it to somebody else, to build the whole process, the process is 10 steps. Well, if 10 people are handling a certain step, well, their customer is going to be different. And then we go the other way and we put the inputs in. And then finally, we put the suppliers in. So drum roll, please. Feeding the dog. This is just a simple example of how the SIPOC works. All right. So again, I'm going to start with process. And if I'm going to feed my dog, the first thing I'm going to do is open the cupboard. Right. And then the second step is going to be, I'm going to get the bowl. The third step is I'm going to fill the bowl. And then step 4, which I never, ever, ever have to do, is call the dog, because the dog is sitting there waiting. And then I go to output. So open cupboard, get bowl, fill bowl. Now my outputs are going to be dog eats and the dog fertilizes the garden. And the customers for this process are the dog, the family, because we have a dog that's healthy and we're feeding them, and the garden. And then we go backward now. And what are the inputs? Well, in order to do all this, I have to go shopping. I have to buy dog food, return home, put the groceries away. And my suppliers are going to be the grocery store, or the PetSmart, or whatever. So something that in the last class, Sean Hassett from Albrecht brought up was he feels like this is a very useful tool because it makes you think about steps in a process that you may not necessarily think of. Like, for example, the one he brought up was, what if I have to add pills or medicine to the dog's food, right? So that would go in, you start with that, open cupboard, get bowl, fill bowl, add pill, crush pills or whatever. And then my inputs are going to be different. And my supplier might be the veterinarian. Okay. So it's a way to kind of get everybody on the same page. So any early votes yet in terms of SIPOC or a map? Like a SIPOC, you can pick any process you want. Process map, you can pick any process you want.
I'll take the SIPOC.
Same.
2 SIPOCs. That's what the last class did too. How many? Everybody in agreement?
Yeah.
Yeah.
Okay. So basically, I'm going to send you the math practice workbook with a kind of a SIPOC template in there, and then you can just do it. And I'm thinking maybe when we return them, we could share all. When you email it back to me for the homework. If you're not worried about the homework, you feel confident or whatever, then just copy everybody, and then we can all kind of see and pick any process you want. It could be in at PTA, Greg. It could be where you're at, or it could be something like, don't do feeding the dog though. I'll give you a 0. No, I'm just kidding.
Feeding the cat.
Yeah, feed the cat. There you go.
Feed the fish.
That's the crafty. Yeah, see, get fish food, fill bowl, put the bowl in the fish. Yeah, okay, never mind. All right. So that's that. Now, value stream mapping, I want to kind of go through quickly, and I think the folks at PTA saw this like an introduction on Tuesday, so it'll serve as a good review. But it's a method to take the mapping process and put it on steroids, really. Because what it does is it starts to put an element of time into that process map. You remember the process map that we looked at, bing, 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 bing. There's no time element here. It could take a year, it could take a week, it could take a day. Now, when we get here to the value stream map, we introduce time to the processes, all right? It's the same thing. There's a textbook that I promised Greg called Learning to See. That is called Learning to See because the idea is that the mapping process allows you to see waste that you can't see by the naked eye. Like once you get past like the glaring, you know, in your face waste, a tool like value stream mapping helps you see beyond that. Because again, like even after you lean out a process, a real good lean person would be able to go in and look at it and say, hey, there's probably 80% waste here still. And I'm gonna kind of try to, folks at PTA, I want to do my Lego planes and kind of illustrate that for you in terms of making huge quantum leaps and improvements and how many planes we could do in 6 minutes, and then yet still finding more and more and more waste. And value stream mapping is a tool to see waste. And again, you guys know what non-value added work is from last week. It's those 8 wastes. You know, you use downtime, defects, overproduction, waiting, non-essential processing, transport, all things that we do that you can't invoice your customer. It's non-value added. Take them out, right? And so the map helps us see which activities are value added and which ones are not. So this one here, when we talk about a value stream map, now we're talking about from the receiving door all the way through all of our processes by which we get the order into our plant. Like in other words, how do we get it into our production planning area? How do we get it to our buyer? You know, so it's much deeper dive into how the process flows all the way from we get order all the way through to how do we buy our raw materials, how do we get them all in, and then each step of production. So it's not just production usually when you do a value stream map, it's the whole thing. It requires more detailed information, and we're going to do one. I think we'll make it A3. We had talked about it last week, Greg. You know, I think what I'm interested in doing is just the best way to learn is to actually do one, because when you watch a PowerPoint, it sounds more complicated than it is. But we will look at cycle time, prep times, how much working time you have during the day, or you know, the 3 shifts. What's our available work time? What's our scrap rate? Those things are all can all be documented on a value stream map. And this is kind of what it looks like. There's a lot of symbology on a value stream map. And you'll see that the way it starts, it always starts in the top right corner with my customer. And this is where demand is. So it's largely you take the demand that the customer has and you translate it into time units. So it's so many minutes per piece or seconds per piece, depending on what what you do. And then it goes from the top right, and we move straight left to production control. When you see ziggity zaggity lines like that, it means it's done, you know, electronically versus like handing somebody a piece of paper or yelling out the back door to them or whatever. And then if you continue left, you get into the suppliers, and then the inventory is those red racks. You see the racks there right underneath the truck that's pointed to. So you kind of even take your inventory and you translate it into time units. So for example, plastic pellets, for example, blue. Well, how many days worth do I have? So this value stream mapping process is about taking all of your processes and turning them into time units. And then from our supplier, then we move from left to right with our actual production processes. So the cells that it moves to. And again, there might be inventory. So you see those little bread racks there, you know, the little zaggedy line, you know, the in between. So you're tracking your WIP, and then there's a data box for each step where you're looking at how many people there are, what's the tack time for that operation. And basically the home run, the money shot for a value stream map is the bottom line here. See the line right up, see the gray box on the bottom. I don't know if you guys can't see my arrow, huh? I don't think.
No, we can see the bottom line.
Okay, so there's a ziggity line there. and one of them says
Yes.
6.5 days, and it says 1 hour or something. Then one
Says,
day.
System lead time, 4.5 days,
Yeah,
processing
then it says
time.
1 second. You see, so basically the value added time is on the lower one, the one that's lowered. That's the
Yep.
actual amount of time that where you're actually doing something without the waste. So when you get to the right corner, you see a summary there, and what you're going to have there is total processing time, which is going to be measured in days or sometimes weeks. And then the value added time is usually measured in minutes or seconds. So the idea, the strategy is after I map the process out, I'm going to try to compress those two together. And a lot of times you can make a lot of big strides because basically your inventory, like say the inventory here is 2 days. Well, if I cut that inventory where it's not WIP, it's continuous flow. Well, guess what? I'm going to take out a whole bunch of production time. All right. Because in lean thinking, inventory is thought of as time. How many days worth do we have? How many minutes worth do we have? All right. So I think the best way to learn value stream mapping is like everything else, learn by doing. So the idea is let's pick one value stream, could be one part, and let's map it. Have some fun with it. And then teach everybody, everybody get more used to it. I like doing value stream maps on my clipboard with a pencil, and you have to have some kind of a timing device. We measure tack times, things like that.
Hey, Bill.
Yeah.
This brings up an interesting scenario that was played out here at the Boston VA last week. So when COVID hit, I think everybody was sort of unprepared because they didn't have enough supply. And then as the process began and the response it ramped up, we got more supply. And now we have a lot of supply. And the regional office is trying to formulate a plan to take care of the supply, but also store it. And my understanding is from the bigwigs down in Washington, they're just saying, yeah, let's just spend the money and either, lease a building or build one eventually.
Thank God they don't have to make a profit, right, guys? The government.
Well, yeah,
Thank God.
I know, but you're saying that if you have too much supply, that's a problem in the private sector. But what do you say when you go into a pandemic type of situation, or even some sort of incident that slows your business down, such as a fire? Do you have a magic amount or magic number of supply that you want on hand to keep your continuity of operations going?
Yeah, I don't know. Did we cover Kanban last week? Because the idea behind this is, listen, if I use 10, I buy 10. Or if I sell 10, then I make 10. So the idea is just like a supermarket, wherever they sell during the day, that's what gets put back on the shelves, no more, no less.
Right.
When in cases of, because even in, like PTA's on the call with us, and there might be a supplier has a fire at a plant somewhere. Now, all of a sudden, this all goes to hell. Like in my own business, there's certain things that happen in business where, I got to get all I can while I can,
Right.
but if you can't do that forever, like the government likes to do, because, unfortunately, everybody has to feed their people and make sure everybody gets paid and make money. Right. So,
Right.
So this is about like those kind of extraordinary circumstances, like what happened last week. I mean, it happened like in the steel industry, there was huge shortage in the beginning of the year, this year, so everybody went out and it's kind of like toilet paper last year when COVID first hit. You couldn't find it. If you did
Right.
find it, you were paying $10 a sheet or something, So yeah, I think it all goes out the window when we're talking about crisis management. But the idea is a concept called just in time. We use one, we buy one. Or we sell one, we make one.
I got it.
And when I say one, it means whatever we sold. And that's kind of what the goal is. So we don't have all that inventory that we bang into, have to move around, because it's all sleeping money. There's all dollars sitting on all those shelves. And we can't operate like the federal government, where they have an endless supply of cash. And if they don't, they just make it. So that's the difference. Thank you for that.
No, thank you. I get what you're saying. It's, if you sell one, you have to make one. But in my field, in emergency management, we have to have a
Yep.
stockpile.
Can't run out
But-
because your supplier
right.
isn't reliable, right? You can't just say, all right, I don't know, let's pick something. Test kits, for example.
Well-
Today we did 10,000. Well, tomorrow we're gonna get 10,000. Because you just
Well,
don't
they,
know.
even in Massachusetts, that they ran out of masks, those N95 masks, and they partnered up with the New England Patriots and had them fly all the way to China.
Yep.
And pick up, I think 2 million, maybe 3 million of these masks and then fly them back.
It's again, in crisis management, where what you specialize in, it's probably not as nice and neat as what we're looking at here. But there's a lot of opportunities just to improve quality by attacking all that whip in between steps. And then spaghetti chart, pretty easy. I just did 2 of them today for Atlas, actually, because it's part of their gold question. But it's another way to hand somebody a diagram, and you guys done any of this? And you can kind of see how much traveling around things are doing. You create a map of the work area, first the layout, you observe the current workflow, and draw the actual work path from the beginning to the end, and then analyze a spaghetti chart to identify. I want to just show you the one I did today. I think it'll help. I think it'll make more sense than something that's facetious like that. I'm going to grab it real quick. And it is called there it is. I'm sorry. Here it comes. I'm gonna grab it real quick. I'm sorry. I thought it was worth showing you. So this is one today. This is for a 1-part family spaghetti chart, and largely it starts in the green there. That's where and you kind of track in the number of feet that you have to walk to get over to the first operation, which is stamping and forming, and then you go into deburring, and then from deburring it has to go over to testing. Marking, I'm sorry, and then and so basically it's a way to look at a process, and you see that 1 part, it's going to be about 416 feet of travel on the fling, and then it goes all the way to quality testing. So it's another tool that you can take in. I think it's probably worth doing, at PTA even, for some process, because you get to see kind of and they call it spaghetti diagram because that's what it looks like. Looks like a pile of spaghetti when you're finished. And so the idea is the workflow, is it logical? That's spaghetti diagram. And let me get back. All right, so now the last one I think we're talking about today is the XY matrix. I'm gonna buzz through this quickly. And basically it's a way to subjectively, so again, next week we're gonna get into numbers, but subjectively quantify. It's kind of like FMEA a little bit. Where you kind of put a number to something that you can't really measure with a ruler, right? You kind of do it by opinion, with several X's to several Y's. And remember, Y is a function of a bunch of X's. Remember that first equation that kind of Six Sigma is based on? The Y is the result that I want, and it's a function of the inputs. And the inputs are usually vital few factors, probably 3 or 4 things that impact my Y. And it's basically a tool, the XY matrix, to get everybody on the same page in terms of what are the important X's that we need to focus on. Because maybe there's 7 or 8 of them, and you're saying, well, we're not going to go through and try to improve all of these. What are the vital few that we need to spend most of our time thinking about? So this is what it looks like. Again, it's it's a graph like this. And under input variables, you put all the input variables. And I'm going to give you an example of that in a second. And then there's a way to grade them. And these are the outputs, what the customer wants. So largely, what's the relationship, making it very visible between my inputs and my customer requirements, which are Ys. And then you kind of almost like almost like FMEA, you kind of grade them, each one. Everybody says, yeah, it's about a 5, it's about an 8. You add them all up, multiply them, whatever, and you come out with a ranking, which kind of, then you gain agreement. Ask everybody, does that make sense? So this is what it kind of looks like. There's a whole bunch of variables. Here's the outputs. And then the grades are, the way it works is I'll start with the first horizontal line. You see the 10, 6, 8, 7, 9 there in blue. Right under it says 3. So 3 times 10 is 30. And then 9 times 7 is 63. So 30 and 63 is 93 and 18. There's my 111. And that's how it works. And everybody kind of says, you know, from a scale, on a scale, what do you think it is? So it's very similar, as you can see, to FMEA. And here's an example of a IT help desk. All right. So let's say you're, you know, you run an IT help desk where you're helping people. Like, what's important to the customer? Here's if you look at number 5 here, the first thing, most important thing is that they get fast and easy to get help. In other words, people don't have to wait a long time. And I've often thought about this tool with my wife's frozen yogurt shop. You know, they want to clean. They want the bathrooms clean. They want the floors clean. They don't want to wait when they get to the counter with their frozen yogurt all made. There's a cost element. They don't want to pay, you know, a mortgage payment to get frozen yogurt. But there's a whole bunch of voice of the customer things. And in this case, there's more knowledgeable agents. In other words, when I call the help desk, I don't want to talk to somebody that can't get out of their own way. Like, I don't want to talk to Bill Greeter, who can't figure out how to put the sound on his computer. I want more knowledgeable agents. You know, maybe the customer wants, let's see, was that one? A little bit down. No, I don't want downtime. I can't afford to have my computer down for a while, too long. And then better communication on changes. So those would be all the things as a customer that they may want out of the IT help desk, right? And then down here, there's a whole bunch of ways that I could start to achieve these customer priorities. One, I could add more agents, right? Or I could have more desk side assistants. I can improve self-service portal where people can go in and self-diagnose, you know, and train them on that. You know, now I don't have to, you know, have agents doing it. Like self-healing for known problems, you know, the concept of mistake proofing, you know, have the problem solve itself, figure out some ways to do that, or publish a newsletter giving tips on how to fix your own computer. And then you basically go through it with the team and you grade out which, for example, fast and easy to get help. Well, one would be a 10 for that would be add agents, and a 10 would be self-healing for known problems, right? Now it's really fast and easy to get help. And then you take each one and you kind of grade them out for each of the voice of the customer. And again, guys, it's very subjective, you know, unlike what we're going to be getting into as we get into the statistics starting next week. You know, you're basically getting, it's kind of a gut thing. But if the idea is that if I have 3 or 4 people doing it, then we're going to gain agreement and we'll get a pretty good feel for, you know, which ones do we go after first, all right, to make our customer the happiest. So in this case, self-healing is number 23% total of the total, and add more agents is 20%. So those might be the two that, in order to meet the voice of the customer, that might be what I do. All right. So there's just a few tools. Again, there's nothing too complicated about them. And we're just going to kind of brush on. I only have like 8 more slides, so I think time-wise we're doing great. Some Six Sigma, even though I ate up half of it trying to get on the freaking computer today. But anyway, we're going to get into a little bit of statistics, just a little touch on it. And I think the thing that the takeaway today, I think this is going to be something that you're going to want to think about over the next 6 or 8 weeks, you know, is that there's 2 different types of data. One is continuous data and one is discrete data. All right. And continuous data, when I say continuous data, it means I can measure it, you know, so I can actually measure it. The speed of a car, your body weight, those are all examples of continuous data types. It's also known as variable data. All right. But all you really need to remember is continuous data means I can measure it. Discrete data, on the other hand, is counting. So measuring is continuous, counting is discrete. That's the difference. That's it. For an example, An example of discrete data would be how many cats are in the neighborhood. Well, I can go out and see and count them. I'm not going to measure that, right? The other thing that might be discrete, especially if I'm doing a survey, is maybe pass, fail, yes, no, that kind of thing. So continuous, I can measure it. Discrete is about counting. And if you just remember that concept as we move forward, I think you'll be, I think it'll be very, very clear. Continuous, I can measure. Discrete, I count. And measurement scales, a couple of them here. We're probably gonna go through 4 of them. One is a nominal scale, which is categories, names, labels. There's no ordering scheme possible. Some examples are a bag of marbles contains the following colors: 11 yellow, 18 red, 3 orange, 5 green. There's no order to them. They're just nominal measurement scale. The central location, which we're going to get into next week, is the mode. All right, and the mode is which one occurs most often compared to the median, which is what's the middle. Then there's average. We're going to get into those more next week, so don't worry about that too much. And it's for information only. And then there's ordinal ranking measurement scale, which is ranking categorical data. Difference between values cannot be determined or are meaningless. The central location is median, and the dispersion is percentages. Again, don't get to, this is not something that there's going to be is on the exam or anything. Measurement scales are applying numbers to objects or something according to a set of rules, like measuring your kid's height, for example, right? Nominal, it would be, you give how many boys in the class versus girls in the class. Well, for boys, we'll give them, it's a 1, for girls it'll be a 2, and that's all. So it doesn't really mean anything. Baseball uniform numbers is another example of nominal measurement scale. And ordinal is kind of like placement in a race. The measure of dispersion, when you look at the level of dispersion here, it tells the variation of the data from one another and gives a clear idea about distribution of the data. Again, this is just a flyover. Don't let your head get twisted around with this. I'm just mentioning them just so, like, in case you remember one, you can tell somebody while you're eating dinner or something, but don't get too caught up. The third is the interval measurement scale, and I'm giving it to you because it's part of the, I guess I'm required by law as part of the certification. Interval is temperature in degrees, for example. The difference is meaningful, right? And the ratio means something. In other words, 60 degrees means something when compared to 35 degrees temperature. I think that's probably the best example of an interval scale. And then a ratio scale, things like an extension of interval that includes an inherent 0 starting point. Product X costs $450, product Y costs $900. That 900 is twice as much as 450. So I can see a ratio there, right? And it makes sense. Like, for example, if go back to the baseball uniform one, if I said, hey, you know what, number 40 and number 20, he's twice as good. It doesn't mean anything. Like, what I'm saying? So you can see the difference. So that's population and measurement scales. Now we're getting to population and parameter. And these are terms, again, that we'll be using throughout the class. A population is all possible observations of similar terms from which a sample is drawn. All right. So in other words, if I'm going to go out and sample something out on the floor, the population, all it means is that it's all the possible places where I could pull a sample. Because again, we're going to be talking a lot about sampling, right? Because a lot of times we're not going to be able to measure every single part, and depending on what the problem you're working on is, you're not going to be able to, you're not going to be able to interview every single person, or or poll every single person. So I'm always going to be looking to draw a good sample. And again, a part of the measurement phase, as you'll see, is, and we're going to get into it as we go on, is like, how do I know that I have a good sample that's representative of what I'm trying to learn from that, from whatever I'm looking at. And then a parameter this is an arithmetic, so math description of the true numeric population value. It's often unknown. It's estimated by a statistic. For example, population mean and population standard deviation. Like, those are things that I may not know. and they're often estimated. And then a couple more terms. One is sample. It's a randomly selected set of units, values or items drawn from a population. So we just talked about that. And a statistic is defined as a numerical value taking from a sample data that's used to make an inference. In other words, data just, it doesn't talk, right? It lays there on the page. But I know a statistic is a numerical value from a sample data set that can be used to make an inference about a population. All right. And again, next week, we're going to get into mean, standard deviation, mode, all that stuff. We'll have some practice with that. So here's a couple of examples of some statistical notations that you're going to see this chart a lot on and on. Because a lot of times, you're looking at formulas and it'll have capital N equals something. So this is what they mean. It's nice to have handy until you get used to a lot of these things. Some of them are Greek letters, things like that. But these are like standard deviation we use a lot. We're going to be using quite a bit. The mean, the mu here down the bottom, second to the bottom on the left. We'll use that a lot. Sample size is always a small n, but there's a common language when you're looking at statistics and formulas. Again, this is not on the exam. And then data collection guidelines and sampling techniques. I just want to cover this, and then we'll call it a dinner time. So here's the data guidelines in collecting data. We want to clearly define first what we're going to measure. We're going to define the characteristics we're going to measure. We're going to select the right measurement tool and techniques. We're going to establish who's going to collect the data. We're going to select an appropriate sampling method and decide who will analyze and report the results. So those are kind of the steps. And there's two types of sampling. One is random sampling, which requires giving every part an equal chance of being selected. And the sample must be representative of the lot of the population. And then stratified sampling is sampling from a subgroup of data that reflects a population parameter. For example, what's the average height of children in the 3rd grade? That would be an example of, so I'm not going to sample every kid. I'm not going to measure every kid in 3rd grade, am I? All right, so that's just a brief overview. These are going to keep coming at you, so it's the first time through. And then next week, we're going to start with descriptive statistics, which are not only are we're going to start to measure in some different ways of measuring. I think I don't want to go any further than that. Let me see. Yeah, I don't want to go any further than that. We'll stop there. Not bad, right? So we're going to do SciPoc next for homework. I'll send it off with the recording. I'm thinking, guys, is it okay if I give you guys the slides when we get done with measure, like I did with define? I'll give them to you all at once instead of just doing, because we're doing three measure phase. Weeks. Is that all right with you guys?
Yeah, we have them in the video anyways. If we
Yeah,
need
you
to,
have them in the video, as I kind of figured, when if anybody needs help with the homework, the SciPoc, please give me a buzz. Let me know. Happy to help you. Kat, don't spend more than an hour on it.
Yeah. Well, if I need to, I have to. On my ducks in a row.
Yeah. All right. Thank you, people. Everybody good? Yeah.
Mhm.
Right.
Yep.
All right.
Good night.
Have a great night,
Good night.
guys.
Thank you, Bill.
too.
Thank you, guys.
Later, guys.
Hey, everyone.